Okay, our next talk is Tales from the Hunt, and it is hosted by Tonimir Kisasondi.
There you go. Hi guys, you know me probably, but first a public service announcement. At 19:15 the lightning talks will be here. Submit more talks for the lightning talks. We already have some amazing presentations, like stuff how guys were setting up gaming rinks and how clients try to cheat them, why Vim is so awesome and uses HQL for navigation, stuff like the new stuff in the Google Chrome, and how Google Chrome is spying on you in new ways for the last week. Submit more talks, come to the lightning talks there today in this room, it will be awesome. Okay? You still have time to submit something. It's 5 minutes and you can talk about anything. You're gonna love it. Okay, and now for the talk, right? So I should be probably talking about this. I'm Tonimir. I was working for 10 years in academia, and then, well, I said that I decided to quit academia and work more with the industry. I'm the guy who organizes FSEC, the Croatian InfoSec conference, and I'm a guy from OWASP Croatia. Together with Vlatko Koštoriak, we had the OWASP Croatia chapter. And I'm a red teamer. I like to break stuff and learn how it works and to see how you can improve something. So, pop quiz, we're going straight to the head. How many of you are doing development work for others, or you're developing a product? Okay, you're developers. Okay, how many of you who raise your hand you think that you're writing secure code? One. Challenge accepted. I was hoping somebody's gonna do this. Sir, in the next 30 seconds, locate the bug, security vulnerability in the following snippet of code. Chop chop.
It's Bitcoin.
Money to gone. So this is like one thing is pen testing. You have a live system and you need to you're just throwing stuff at it. You try to see what will work, but source code reviews are way more better, because when you're reviewing source code you can see stuff like that. And for instance, the vulnerability is like burning in my eyes, but you need to know what you're looking for. And loads. Why is pickle loads a problem? Does anybody know why pickle loads is a problem? Okay, how many of you know that? 1, 2, 3. Awesome. So I usually like to add the text from the documentation to my slides just to make the whole thing a little bit more dramatic. And when you look at Python library's pickle documentation, I know it's from version 2, version 3 is same. Since pickle data format is actually a tiny stack-oriented programming language and some freedom is taken in the encodings of certain objects, it is possible that two modules produce different data streams for the same input objects. However, it is guaranteed they will always be able to read each other's data streams. Interesting. And what's actually pickle? Well, a pickle is a serialization format. You'd use it usually to thank you, kind sir. I won't reject that. Thank you. So pickle will help you to encode a certain blob of data, and that certain blob of data will be deserialized at the other stage, and the system should turn it into an object, into anything else. But a pickle can encode anything, as it's a stack-based programming language. And in this case, if you use the embedded pickle payload function for reduce, you can just tell it, okay, return OS system and execute who am I. If you check out what pickle data actually contains, you will get this here binary blob. And if you execute it, here is who am I, but you can execute shells, anything. This is a snippet from the pickle programming language. And here you can see something pretty interesting. C means load a module until the new line, and the second argument after the second new line will be the name of the object you're trying to load from the module. So this is literally doing import POSIX.system, and it will put on the stack call just for POSIX system, add sh and execute this. So if you have this payload and you use this payload and you send it off to a any other endpoint that deserializes pickle format, you got remote code execution. Well, it wouldn't be so bad if like people would actually read the manual. How many of you read the manual when you are using something? Yeah, great. You at least, how should I say, you at least don't risk the part where, you know, the instructions are unclear. Unfortunately, in the manual it says, pickle module is not secure against erroneously or maliciously constructed data. Never unpickle data received from an untrusted and authenticated source. But still, you will find a ton of examples, because usually people Google and go on Stack Overflow. People say, yeah, sure, just pickle it up. It's okay. But yeah, pickle is just a single occurrence of a bad library, right? It can't be all dumpster fires just down below. Let's use something better. Let's use YAML. Like YAML is also popular for config files. What could possibly go wrong? YAML is a config file format where you have a certain formatting for a config file, and you can say from YAML import blah blah blah, and then you can do load. Where's the vulnerability? Loading unpickled format, or loading a specific object. And in YAML, you can just simply put 2 exclamation points, which mean, hey, execute this object, Python object, apply OS system, download something from this web page. You can execute it, and it can execute commands. And if you load an untrusted YAML file to a system, boom, code execution on that machine. Yeah, okay. YAML's documentation clearly states, in small print, it's not prominent as with pickle. In pickle, like you have a big red box telling you, I hope you know what you're doing if you're using this module. The YAML says, it's not safe to call YAML load with any data received from an untrusted source. It's as powerful as pickle load, and so may call any Python function. Check the safe load function though. Okay, at least first thing I have a problem with is non-defensive programming. If you use YAML load, it should at least print like a non-standard error or something like, this is unsafe. Make sure that you add this flag in order to enable unsafe functions. Because YAML will parse the YAML file and create a Python object for that. Third time's the charm, right? Let's use JSON. Like nobody uses pickles, YAMLs. Let's just simply use JSON. So guess what happens afterwards? We can go over this list for the next 16 hours. Why? Because the core root of this problem isn't pickle, isn't YAML, isn't JSON. The core root of this problem is something called insecure deserialization. It's number 8 on OWASP's top 10 for list for 2017, and it is not limited to only YAML pickle. It is limited to any serialization format, including XML parsers, JSON parsers, custom serialization, compression, whatever. If it stores or packages something, it is probably vulnerable. So what are we talking about here? First, find your own favorite serialization format. There is a couple of good cheat sheets, like the Friday the 13th JSON attacks and Java deserialization cheat sheet from Gerdog, which is awesome resource where you have a nice spreadsheet with all the versions of software and which of them are vulnerable. And I got a plug Costs project here. He wrote on Docker, Vuln Deserial, there is a small playground where you can load a Docker container which is vulnerable to insecure deserialization attacks, and you can try a couple of them, and you can play around with it to see how the code looks, and you can see how the actual vulnerability is getting exploited. So depending on the code, depending on the library, depending on how the serialization is being done, you need to find a gadget that leads to our RC. It is very dependent on the library, on the language and everything. You exploit it, most likely you will execute commands on that machine, which is awesome. But finding a gadget that will execute and end in remote code execution is pretty difficult for almost every popular language out there, right? Fortunately, like one project and one language that I like, I know, no, don't start throwing stuff at me, is Java. Why? Because a lot of stuff is written in Java, and at the same time, a lot of deserialization is happening in Java. So there are a couple of guys, Frohoff, who wrote a nice little tool called YSO Serial that will enable you to create gadgets for various type like Bean Shell Common Collections, Hibernate, JBoss, JSON1, I don't know, Mozilla Rhino, Spring, Wicket. There are some other like Jackson and other libraries are vulnerable, but that's not endemic to Java. This is a tool just for Java. If you have anything else, check those links. They can give you more info on various other deserialization formats. In that case, it is not that difficult for a script kiddie to prepare a gadget that will, under some circumstance, will result in an RCE level attack against anything if you allow input to be deserialized. The mitigation is really simple. You should use safe libraries, you should use data-only formats and read a bit, because check out your libraries. If you're using libraries and if they're unpacking customer-supplied data, treat it as any other unsanitized data. If you're not careful with it, you can shoot yourself in the foot. That's an important thing to know. And here, there is one very important thing. Sometimes you will optimize for breadth. For instance, you will optimize to catch as many vulnerabilities in as short time frame as possible. Vulnerability is a less or more successful variant of doing that. Sometimes you want to optimize for a specific hypothesis. We were looking at a talk that was about how to design a hardware secure Bitcoin wallet and cryptocurrency wallet. In that case, you can test a specific hypothesis. Can I extract the private key from this unhackable wallet? If you want to have a couple of laughs, I would suggest Googling Bitfy wallet for just some giggles and how not to develop stuff. But such a hypothesis testing is way better because you can concentrate on a specific task you're trying to accomplish. Unfortunately, a good thing is that most issues can be caught by simply reading the source code. Take your code base and check it out. Check out what's happening. Like, be a little bit more critical about it. If you know that pickle loads is a problem, if you know that like loading, deserializing stuff is a problem, how can you use that to our advantage? Well, if you're always missing 0 days and you don't know, like you need exploits and you want to weaponize stuff, I would suggest using the modern exploit and 0-day search engine called GitHub. If, for instance, you enter pickle.load, well, for the last 20 days, you will get pickle loads, added pickle loads, unpickling. So, for instance, you get some interesting stuff, like you would find, oh, look, there are a couple of tools that also add some pickles to their collection. And it's fascinating because you will find the use of those functions at the time somebody pushed them in. Probably after some time, somebody will say, oh, you morons, you added deserialization, this is vulnerable. And unfortunately, I didn't put a picture, but I just found it out. Like, I was searching for some vulnerable pieces of software to show this off, and then I found a not really quite popular piece of software, but it was popular because it was for a popular company. And I searched for code, and it looked like 160 issues found. Press issues found. And I found there, check this out, it said, hey guys, I found a deserialization vulnerability here. It happens when somebody sets a specific gadget to this URL, blah, 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 blah. I'm like, interesting. No reply. You check out the source code, and guess what? It's vulnerable. So in GitHub issues for public projects, you can find really amazing stuff. You can find also literally stuff you can exploit. So in short, if you're not doing internal code reviews for security issues and you're not deliberately hunting for stuff like that, like, okay, let's hunt for injection vulnerabilities, let's hunt for broken authentication, let's hunt for insecure direct object references, broken authorization, like focused code review on one thing. If you're not doing that, you're being irresponsible. I'm sorry to put it to you. If you don't have to get wild. People usually think when, like, giving effort into reviewing and refactoring, people usually think, oh yeah, that's going to be a lot of work. That's like going to be 4 or 5 weeks. you don't have to get wild about it. But if you spend 1 day on reviewing or searching for specific vulnerabilities, it is still better than spending 0 days on that. I mean, pun not intended, but well played. Let's play a game. So, who wants to find the vulnerability? What? Yeah, you can load local URL. And what can you do with it? How? Okay, so you're thinking this is a local file inclusion vulnerability? Excellent. That's a good. You've fallen back into my good graces now. So, yes, this is not a local file inclusion vulnerability. This is something way more interesting. I found it I was Googling just to find, okay, I need a piece of vulnerable code, and I feel bad ripping off other people's presentations. So I was like, let's find something on GitHub, and we can link to the project with the vulnerability in it. So, is this a 0 day? I don't know. I think not. But interesting point. You have CMS, and you have an URL which will get fetched if you pass up certain post requests to that URL, and then the system will create a request to another system and fetch some data out of it because it's a CMS. This is very, very, very popular in certain areas imagine API, centralized APIs that connect to other APIs, systems like that. So, you can enter a URL and you will execute a curl, a GET request to another URL, right? This is stupid. What can you do with one simple URL? You were right, but in a way, yeah, you found out the file handler. Exactly. That's one thing you can do, but that's not everything you can do. So imagine this. Making arbitrary requests suck, right? Why should you care? Well, if you use Amazon, then on this little fancy IP address and this little path, you have the internal metadata system for Amazon's, your local AZ. You can also check the AC2 instance metadata, document, which will give you all interesting reconnaissance info that you ever wanted. So instead of doing externalized reconnaissance, you need to do recon, you just simply query this Amazon server and you would get all the AC2 instance metadata you would ever want. You can call internal APIs like user management, user blah, delete. You can call internal web interfaces like databases, systems. This is also a problem if you have a full SSRF where you can get the output from the request. For instance, web interfaces for MongoDB, some other system like Elasticsearch, Kibana, you're proxying directly into the network after that. Files, well, you don't have to write HTTP column / you can write file column / etc passwords. You can fetch local files from that. And one interesting part, as this is a GET request and you're literally crafting a HTTP header. HTTP headers are literally text, right? So you can do something cool called protocol smuggling. If you end, for instance, get CRLF, you end with CRLF, carriage return line feed, you can add specific other info. So you can craft other types of protocols like SMTP, so you can send spam through their internal mail server. You can do all kinds of interesting stuff. And as I was researching this, I found an awesome tool called SSRF socks, which you give it an endpoint that's vulnerable to SSRF, and it will generate a local socks proxy where you can use proxy chains to use the local socks proxy, and then simply you're inside their internal network. So it's like piercing firewalls through web applications without actually touching the firewall. No, I like that. There are also file descriptors. There's PHP interfaces for PHP inputs where you can get the whole request. There's amazing stuff you can do with this. But there are two variants. First off, you got something like a non-blind SQL injection attack type of SSRF vulnerability, where you have a direct SSRF, which means you get a response and you send a request, you get a response, you see the response, that's it. Or there's something called an indirect SSRF, where your system will send a request, not your system, I mean your victim or your system you're testing, will send a request to a third-party system, but you don't know if it's vulnerable. How will you test for vulnerability? Remember Boyan's talk from last day? He said, well, you can always extract one bit of data at a time, right? You can enter a system that should work, and then you can enter a system that you know it shouldn't work, and if it's making a GET request, it won't execute immediately. It will have a timeout, and you will know that this system is not active, and you will see it in the timing. There are also some restrictions on SSRF. People usually do whitelisting, and this is a cool thing. Does anybody know why this works? Because, for instance, an IP address, a host name, you don't have to represent it as a normal URL or normal IP address. You can convert the IP address to a decimal variant, and it will work, or an octal variant, or a hexadecimal variant, or you can simply convert segments into octal variants and connect them with dots. So, for instance, if you want to use this, you can use this to bypass some filters. There are also all other kinds of stuff. And since this is text, the same thing how the SSRF proxy tool works is it will add carriage returns, and you can simply add the rest of the protocol, inject headers, do amazing stuff. So SSRF is kind of amazing, and you can do all kinds of weird stuff with it because it will become your internal proxy and your internal network endpoint that you can use. Like imagine SSRF as an open SOX proxy. That will be the easiest way you can find it. I like to plug local researchers also when they're here. There is a guy from here that's called Predrag Čujanović, who has in his GitHub an amazing set of resources for SSRF testing, where he has specific vulnerabilities, payloads you can test. And some researchers created a nice Bible, that's the second link, where they give out a list of all of the known, how should I say, all known SSRF cases, exploitation types, protocol injection, protocol smuggling methods, some ways you can exploit. So if you're more interested into that, I would suggest you visit those links. And also, I would give you a warm suggestion. You saw Cost's deserialization tool. There is an SSRF lab, which is also like a container you can use to learn deserialization or check out deserializations. Important thing here, one thing that will help you always is try to develop a piece of software that is vulnerable, intentionally vulnerable, and then try to secure it, try to change it a little bit, and see how the vulnerability behaves. See why the vulnerability is there, what will happen, because if you know something is vulnerable and how you got to it, what's the easiest way to get to it, you will more easily, A, find it in code reviews, B, you will more easily know if something is like a problem. So what's the moral of the story here? You just given out some tools, you just given out some problems. Is there a moral to this story? Well, there is. My experience is systems get breached or vulnerabilities happen for either complete lack of clue, people don't have knowledge about server-side request forgery, they don't have insecure deserialization knowledge, they don't know why their authorization authentication system is broken, and that's usually seen when you're doing a pen test, you're doing your source code review, like the whole report looks like a bad behavior letter from school, it's totally red. Or omission. People know their stuff. People are really good developers. They're awesome. They know what they're doing, but they had a problem with omission. They missed something. You fix the first one with education. I'm trying to do this right now, because at least now you know deserialization is a problem, and you can fix the second one with awareness, like making sure people are aware, making sure you review code, and also you need time. you need to allot time for refactoring, code reviews, because if your organization is not adding code reviews and refactoring of code, polishing up that stuff in your internal process, we're not talking about somebody else doing it for you, we're talking about you doing the lifting, well, you have a problem then. So do you know if you write secure code? Well, it's not about what you think, it's about what you can prove. If you can't prove your code is secure, you're doing it wrong. Is there a piece of truly secure piece of code? No, because like we thought that some piece of code was secure and that it was perfect, but guess what? Spectre and Meltdown happened. That code, as secure as it is still running on an insecure platform. That code, as secure as it is, might have a side channel attack because of the physical implementation of that system. But do you have to be truly secure? No. What you have to do is you have to do two things. First thing is mitigate risk. Fun fact, do you know that this little guy here, which is a nice hippopotamus, kills more people than lions? Why? Because people usually don't perceive the risk of those animals. Same thing with vulnerabilities. You need to perceive the risk that something bad will happen, that those vulnerabilities are a big issue, and they are way bigger issue than some other things that usually people think are more important. And you need to start building stuff to be secure by default. Usually people think, that stuff is security's problem. Security will handle it. Oh, you just give it to the InfoSec department, let them do that. But everything should be built to be to be secure by default. In fact, security at all is a maturity problem in an organization. If your organization isn't thinking about security as a maturity problem, okay, we currently don't know what we're doing, or we know a little bit what we're doing, and if you don't know at what phase, at what capabilities, and what vulnerabilities or what mitigations are in your code, if you cannot argument that and cover it up with paperwork and everything, you're simply doing it wrong. You're not having a mature security organization. And I usually like to joke about it, but I don't know. Because I say, there's no need to secure system. There's always Blood and Vlad who make excellent pen test for free. Usually you scrape your data off Pastebin, but it's still. There are no easy victories here. You need layers of evolving defenses. And let's not make world like this. You have DevOps, they're unicorns that get really big paychecks and they're amazing and they do amazing work and it's all rainbows and sunshine. And you got the security team. That doesn't work. Things should work like this, right? So you need DevOps, you need security working together in order to build secure products. Arbitrary cat and weapons picture. Question? We have enough time to grill me with as much questions as you want.
So, as I know that you do consulting and pen testing, do you have some customers which are not learning the stuff, that you say, hey guys, you're fucked up, please fix that, and say, okay, we'll do, and then you come again and they're did nothing?
Well, it's a difficult question. You cannot never talk about specific cases.
Yeah,
but in general, I would say that in private companies that live and die by their security in their operations, usually I would be very, how should I say, mid-level startups are usually really responsible about this, and enterprises where money and other stuff is really handled. Because initial stage startups are live and die by the idea of your product, and when you need to ship a product, and when you're going into MVP, and when security is a deal, and that's a deal breaker if it doesn't work, then usually they start taking this thing seriously and they will start evolving. Because my opinion is the whole thing is like a saddle, There is a lot of work and it's really difficult work because they don't know anything and they need help. And then at one stage, they don't need you at all because they got their internal teams and their internal teams are handling. And then it ramps up because they need a third party to look at stuff. we already did this. You see, this is what we do. We reviewed code. These are the metrics for the vulnerabilities we found. And they can argument stuff that they did. They're like, are we missing something? Can you check this? Like, we know. And it's like a joy to work with those companies because they know what they're doing. But well, it still depends, right, on a specific company. I can give you my example for that stage, right? More questions?
Awesome talk, thank you very much. Is there a specific reason why the two teams like devs and security guys are not really working with each other?
Well, it's not that they're not working with each other. Currently, we have a movement called DevSecOps, where security is a part of the DevOps. Yeah, blockchain, IoT, AI, machine learning, deep learning. We done with this? Okay. So, yeah, they're working together, which means like the whole buzzword of DevSecOps is like you have DevOps, which was like, let's add a process into the deployment of our software and building our software. Then it's like, we have to think about security in the whole process. So let's just add some security work into the middle. Like you cannot deploy code that's runnable. So, yeah, I currently think that people are starting to get more and more conscious and aware about this because it's a make or break situation in business currently.
All right, thank you.
Anybody else?
Questions? Well, you can bug me in the lounge if you want to, but I'm staying for a cost talk. Thank you very much.